hope everybody's doing well. Hope you're getting ready for a break.
First break I've had in 2 months.
Yeah, I hear you. Well, it's definitely well deserved. I know people are working really hard this quarter. And I know a lot of you are taking physics, which is like extra work, and you're taking math and all of that stuff. So yeah, break will be good. I got one meeting.
Is no joke, man.
Yeah.
Got 10 hours a day some days.
Yeah, you know, I was thinking about it when I was an undergrad. We had 2 years of physics, and I think it covers the same stuff that we cover at Clark. So, but it was 4 semesters. So it's a pretty intense curriculum. So, but I have one meeting after this class, and then I've got a break. So, so looking forward to that. I have office hours posted for tomorrow at 11, so I'm going to sleep. So I'm not going to do 8:30 office hours, but I will be in from 11 to 12, and that's on the ENGRCS schedule. So if you want help with final questions on PA5, for example, that's your last chance. Would be tomorrow, office hours at 11. Well, we can definitely talk about PA5 here. Also, only about half the people seem to have turned in their SLP proposals, so unless everybody's working in groups, I'm missing a bunch of those uploads. So if you have slip days left, you can take a slip day and turn it in late. But it's you know, half of your SLP grade is that upload. And it's just a one-page poster. It's really just taking what you've done so far and just writing it up. The format is already set for you. Just take that file, type in, you know, a paragraph or two for each section, save it as a PDF, and upload it. And then you're done with SLP for this class. All right. So any questions on SLPs or on AUK or on PA5?
I got a quick question regarding my SLP. So I'm going to use Unity. Obviously, I talked to you about. Do you know of any good resources? Because I know the languages used for Unity is like C# and Java.
Mm-hmm.
Do you have any good resources that I can do some research and get a little bit more input on formatting and you know, syntax of those languages and stuff like that?
None that come to mind off the top of my head, but I think if you start going through the Unity tutorials themselves, you'll pick up, you know, some of the basics as far as syntax for the language, and you'll just kind of like learn by doing it. Somebody just posted Udemy is good, is really good, they said. So that's one to check. And we'll learn Java in spring, which, you know, is pretty late in the game for an SLP, but we'll learn Java then. And if you learn C# now, right, that's going to make Java easier, because basically object-oriented is more or less object-oriented, and whatever you pick up now will just help you later on. So
yeah, I was running through some of the scripting on some of the tutorial projects, little template projects,
Mm-hmm.
to kind of see if I could pick up some stuff. And it is weird how they call on their functions, and some of the syntax they're using is just different than what we're used to. You know?
Mm-hmm. Right.
So, all right, I'll check out Udemy.
Okay, cool. All right, other questions, comments? All right, well, go ahead and send me an attendance ping. Let me know who's here. I haven't decided for sure, but if I keep doing attendance pings for winter quarter, I'm probably going to change it to a web page or an app or a utility of some sort that I'll call for an attendance ping, and you'll go ahead and just hit something on a web page to let me know that you're here. I'm also going to try to automate the whole slip day arrangement so that you don't need to talk to me about slip days. You can just run a utility or do something on a web page and say I'm taking a slip day for this assignment, and it'll automatically, confirm that with you and keep track of it and so on and so forth. So hopefully some of these things will be cleaned up a little. I could do something like the assess program, except I also want to use this for my other classes, and I don't have a way to guarantee that my students will have access to the server, especially like Engineering 250, where they're not using the server yet. So, but something like that. So we'll see.
I think that would be a pretty good job script.
Yeah, I think it would be fun. It may be my reward to myself over break if I get other stuff done. Go ahead and fire that up. All right. So questions on PA5? Associative arrays, things like that. All right. Well, my plan for today is to talk about SED. And yesterday we talked about awk, and awk is really kind of the mindset of, you're reading input from a file, but you're thinking of your input as, a bunch of lines where each line is broken into a set of fields. So these might be space separated, comma separated, whatever. But we want to do something with each line. We want to take this and we want to see if this field satisfies some condition. And if it does, then we want to swap this field and this field, or things like that, right? So that's awk. SED is really more geared towards, a line at a time. So we want to do something with, lines between here and here, or lines that have some characteristic on their input. And we may want to insert things or delete things, line by line. And so that's kind of the mindset of SED. And SED is covered in the textbook for the course. So somewhere down in around page 300. Let me see if I can get there. It's a big textbook. Alright, it's down around page 290, there's SED. And it talks about a lot of what we're going to talk about today. So if you want an additional reference on the SED command, you can look in our textbook. But we're going to go through some of the basic commands here, and this will give us a pretty good synopsis of what we can do with SED. So working line by line, right? And the basic setup is similar to awk, which is the command SED is followed by a program, which we might, just put in single quotes, and then an input file. And if we want to do a more sophisticated program, something more than we can just, put in one line here, we can use the same dash lowercase f switch followed by the name of a program file and then an input file. And in either case, the behavior of SED is to read lines from this input file and apply whatever we have in our program to each line of that file. And then whatever output is produced is sent to standard out. And if you look at the manual page for SED, it gives you some information on this. But general comment, right? Input file is listed inside brackets. Brackets in these documentation pages usually mean an input is optional. So just like most other things in Unix, if we don't specify an input file, SED process is standard in. And so we have a few choices. We can say SED, program name of an input file, and it'll read from that file. Or we can leave this blank and it'll read from standard in, which by default means our keyboard. Or we could redirect from a file with a less than sign, or we could feed the output of another command by saying other command pipe into SED. And that's the version that you've been using so far. Yeah, go ahead.
So on the man pages, so the curly brackets are something required and the other brackets are just optional?
Curly brackets, I'm not 100% sure. But yeah, so curly brackets look like they're required. And if you have pipes, that's an alteration, so it can be any of these, right? Those are ORed together. And then these are optional arguments and optional arguments.
Oh, I never really thought that.
Yeah, there's a whole list of standards for what this synopsis looks like. And brackets are definitely optional, so you can just say ls, or you can say, all this other stuff. And VI, everything's optional, right? You can just say VI and get into an empty window, and so on. Interesting. All right, so our two usual ways to run SED, right, with or without a program file explicitly specified. And the default behavior of SED is to read the input file, execute this program on each line, and then send the output to standard out. And so if I just say SED and I use an empty program, just quote, and we're playing with our foods file from yesterday. So there's our list of foods with name, type, color, and price. So if I say SED quote foods, right, I get a copy of my input file. Nothing happens. It just reads each line, sends it to standard out. Oh, cool. All right, you just got the C# game course on Udemy. Cool.
Yeah, they had a couple add-on courses that were really awesome too.
Oh, nice. Yeah, this is like a really, really amazing time to be studying computer science, or really anything, technology or otherwise. Right now, there's so much stuff online for gaming or programming or engineering or philosophy or all, pretty much anything you can think of. There's these amazing resources online, and if you've got the time, I think it would be amazing to just keep learning stuff. I mean, that's kind of what you do your whole life, but later on you're working and all this stuff, and you got to carve out time to do some learning. And I know a lot of people, probably most people, are working part-time or full-time now, but if you're giving yourself the opportunity to learn, this is just a really good time for it. There's so much stuff.
No, I tried YouTube first, but it's just so unstructured. If you don't know what you're doing, there's a guy that'll teach you how to program certain game physics, I guess, if you will. And it's really cool and it's very informative. But if you don't know exactly what he's doing, if you don't know what he's actually trying to do, it's really hard to follow along. Because he's hit dot game object, this, that. It's like, okay, that sounds really cool, but you're not really explaining yourself.
Right.
This is more of a tutorial for someone who's been doing this for a while.
Yeah, and you can go down this ever bifurcating path of YouTube videos where it's like, okay, so first I have to go and learn this stuff, and then I'll come back, and you try to learn that, and you got to learn some terminology, and yeah, it's harder.
I need a starting point at the beginning. Teach me everything that needs to be there, and then I'll start learning the cool stuff about what we can do with it after.
Right. Yeah, that makes sense. Let's see. We're learning deeper Godot engine for netcoding games. That sounds fun. Someone else is taking C++ on Unreal. Cool. Yeah, and once you learn one object-oriented language, you're pretty good to start switching around. So C Sharp, C++, Java, Python, even to some degree, you know, the version of C on Arduino will really help. When I got into object-oriented stuff, it was Visual Basic 3.0, which is, you know, not considered a terribly serious language, but it was an easy way to learn the idea of objects and some of the concepts of object-oriented programming, and the lateral movement is pretty painless once you've broken into one of those. And if you can do this while you're learning to write games, you know, all the better. All right, so sed, default behavior, read the input file, execute the program. If the program is empty, then it just copies input to output. All right, but we can make more interesting programs than this. Our program looks like basically like some kind of condition followed by some sort of instruction. And if the condition is true, then whatever the instruction says is done. And so one form of condition is we can say, I'm looking for a particular address, a particular line number. Or we could say I'm looking for anything between this line number and that line number.
Do these have to be numbered, like formatted with numbers? Or can you actually specifically target a line number?
You can put in a line number, or you can put things in that are relative, or you can do simple expressions. So yeah, let's play with some examples of this. So some example instructions. First one we're going to play with is just P, which means print. So print out the contents of a line. So let's make a really simple sed program here to print the third line of our file. That's the Oreos, right? So I'm going to say sed quote 3P. Foods. And this basically says, hey, if the line number is 3, let's print out the contents of the line. And when I do this, something unexpected happens, right? It prints out my entire file, but the third line got printed twice. All the other lines got printed once. All right, the reason for this is this default behavior of sed, which is copy from standard in or from the input file and send the output to standard out. And that always happens unless we say -n. So we can use an extra switch -n, which says don't copy the input to standard out. So if I do the same file command that I just did, but I say sed-n 3p foods, that just prints out the third line of the file. So there's a really easy way to get, you know, a particular line from a file out with, you know, a few characters worth of sed program. If we use this format, address, comma, address, that specifies a range of line numbers. So I could say sed 3, 5p, and that prints out lines 3 through 5 inclusive.
Now you can also grep these too, right? Or no?
Like how?
Like, could you use like the grep command to print or to grab out the whole line and print that out?
So I can search for things, like if I knew I wanted the Oreos line, I could say grep Oreos in my foods file, and it'll pull out that line that contains Oreos. But with
Okay,
grep,
that's
it's
more
hard
like
to...
a direct.
Say again?
That's more like a direct search. Like with
That's-
sed, you can pretty much pull out any line number if you want.
Yeah, so grep is searching for a pattern, so it reads each line, sees if it contains this regular expression. Where sed, like this, is searching for particular line numbers.
Okay.
And we could also fake this, right? We could do head-5 foods to print out the first 5 lines. And we could pipe that into tail-2 to print out the last 2 lines, or the last 3 lines. And so now we've got lines 3 through 5. but you know, we got to do some arithmetic and so on and so forth. So this is a pretty direct way to do this. And we can use some symbols. So just like in VI, we can use a $sign to represent the last line of the file. So we can say sed-n 12 comma $sign print foods, and it'll print out from line 12 through to the end of the file. So 12, 13, 14, 15, 16, 17. I think we can do this. Nope. Forget that. I think there's a way to do arithmetic on here, but that's apparently not it. Alright, we can also do something like slash and put a pattern in here. And instead of specifying a line number, we can say, hey, find lines that contain this particular pattern. So we could say something like sed-n if the line contains the string fruit, let's go ahead and execute this p command, this instruction which says print, and so this will print out all the lines containing fruit. And that's the same thing as if we just said grep for fruit.
Is one more efficient than the other, or not really? Speed-wise.
I have no idea what the efficiency would be. But said we can actually write entire programs that have multiple lines of statements we want to do, and so this is probably more powerful in some way. But if we just wanted to search for, you know, fruit inside a file, it's probably quickest just to say grep fruit file. But I don't know what the relative efficiency would be. But you could try it. You could run the command a million times and time it and see if there's a difference. That would be interesting.
I kind of looked up for PA5 some of the like the TR command and sed command, and like what was the most efficient as far as
interesting.
speed, and they were pretty negligible differences.
Yeah.
It wasn't much different. TR was supposed to be the most efficient, the fastest one, but it was by such a small margin that it really didn't matter.
Okay, that's cool. Alright, so we also have a command D which says delete. And if we wanted to get rid of a particular line or a group of lines, we could use the D command. So for example, I could say let's delete any line that contains fruit, and that's interesting. Yeah. So if I don't say P, then it's not going to print, and if I do -n, it's not going to copy by default. But if I just say sed and let's find any line containing fruit and delete it, and I don't say -n, it will print out every line that doesn't have the word fruit. And again, we could do that with a grep-v. It's the same thing. Let's see, would this have been useful in the calendar program to sort the dates in order from oldest to newest? I don't know if this is particularly useful for sorting, but if you wanted to sort dates, you could do something like date-d and give it a date, and then print it out with, I think, a %s to turn it into number of seconds since January 1970, and then pipe that into sort-n, which is a numeric sort, and then use those as inputs to date and reformat into whatever date you want. So that might be one way to sort them. Or I think if you change a date into something like, turn it into that and sort it numerically, I think those end up sorted chronologically also. Cool. Alright, so we could sed 5, 12 delete foods, and that'll delete lines 5 through 12. So pretty simple programs to break things up by line numbers, right? You can use print, you can use delete, and you can specify ranges of lines like that. So another command is Q, which is quit. And this is another option. So if we say something like sed 5q foods, this will basically say, hey, when you get to line 5, quit. And so when I do this, sed is normally copying from standard in, from the input file to standard out. And so it does that on the first 1, 2, 3, 4, 5 lines. But at line 5, it also says quit, and so sed exits, and it doesn't do anything with the rest of the file. So there's a way we could do some stuff on the beginning of an input file. So here's a 3-line sed program. And what does this say? It says on line 3, let's print the input line. On line 4, let's print the input line. On line 4, let's quit. And so I could say sed-n-fp1 foods. And so it prints out lines 2 and 3. And then it quits. I could have said on line 1, let's print, and on the last line, let's print. And that prints out the first and last lines of my file. All right, this says print the first line, this says print the last line. If I said 1D $D, that would delete the first and last lines of my file. All right, so other commands. A for append, I for insert. And these resonate with the same commands in VI. In VI, if you say I, you begin inserting before the current cursor position. If you say I, you're saying begin inserting after the current cursor position. That's an append. Okay? Same interpretation of insert and append in sed. Append will put something in before the current spot in the input. Append will add something after the current spot. So insert comes before, append comes after. And so here's another program, P2, which says if you're on line 2, let's append the following line. This was added after line 2. And then there's a P statement which says print the current input. So if I run this on the foods file, well, that's not what I expected. How about sed? If I run this on the foods file, right, it prints out the first line, prints out the second line, and then it added a new line after that, which said this was added after line 2. So that's what this program does. Alright, P3 also does an insert, so it looks for the pattern cookie on an input line. If it finds it, it will insert, here comes a cookie. And the insert means put this in before the line that you're on right now. And then it will look to see if there's a cookie, and if there is, it will append that was a cookie, and append says put this after the line you're on now. And then it says let's go ahead and print whatever our input is. And so if I do this, my cookies get surrounded with a message saying here comes a cookie, there's the Oreo line, that was a cookie. Alright, another thing that's fairly standardized in all of this is a backslash. And if you put a backslash at the end of a line in Unix, that says basically continue to the next line. And so if you're writing a bash file and you have really long commands, you can put a backslash and continue the statement on the next line, and it all gets glued together as sort of a single statement. So for example, I can say PW and I can put a backslash and I can type my D on a separate line, and there's my PWD command. Or I could say, DATE, and there's the date command. So you wouldn't do this, but if I had 200 characters worth of Unix commands, I could spread out the first 65 or so, put a backslash, continue on the next line, and so on. So sed understands backslashes as well. And so we can do something like this. I'm going to look for the pattern cookie, and if I find it, I'm going to insert, and I'm using a backslash to say, hey, let's insert an empty line, followed by, here comes a cookie. And if there's a cookie on the line, I'm going to append that was a cookie, followed by an empty line. And then I'm going to print. So this is going to do the same thing as our previous program, except it's going to put some extra space before and after these lines that were inserted and appended. Alright, we also have a C command, which is for change. And so we can say sed, I'll do a sed-n, and I'll search for fruit, and I'll change that to no fruit. So it's going to read each line. It's going to, actually I don't want that dash in, because I do want to print each line, but each line that it reads in is going to look for this pattern fruit, and if it finds it, it will change the input line to just say no fruit. And so now I've got my fruit lines replaced with, something that says no fruit. Alright, and there's another command that you're all familiar with. This is S. S is for substitute. And this is the version of sed that you've been using for PA5 and possibly for PA4 as well. Substitute... substitute cheap with inexpensive foods, and so cheap got replaced with the word inexpensive. And this thing that we've been doing, this is a one-line sed program. It's a sed program which says substitute this pattern with that pattern. And so we could make a file that contained multiple substitutions. So now I've got 3 substitutions I want to make. So I can say sed and execute the file SSS on my foods input. And so yellow got uppercase, cheap got replaced with inexpensive, and cookie got replaced with dessert. And we could do this from the command line. We could do this substitution. We could pipe the result into sed with this. We could pipe the result of that into sed with this, and get the same thing out in the end, right? But this is more kind of when you're in the mindset of, I've got all these manipulations I want to make on a file, and I can do these with various sed instructions. You can write one program that basically contains all these changes you want, and then you just execute sed once. Yeah, go ahead.
Is this how updates could be implemented? If you're updating a program or something like that, you can just use this file that you created and have it modified into program.
You could do something like that. So for example, if you wanted to change a variable name, you could write some sed script that would do that for you. But probably the better way that you would do that is with the patch program. And patch is worth looking at. I don't think we're going to go through it in here, but patch lets you specify in a very precise way what changes you want to make to a file, and then you can say patch this file with these instructions and it'll turn it into a new file. And you can create a set of patch instructions by using the difference command. So you have file 1, file 2, you do a difference on them and save that result. And then if you give somebody that result and they have file 1, they can use it to create file 2 from it. And that's the more standard way to do updates.
So when you're doing updates, you're basically, as a developer, you're going through and just basically modifying the code that you already have, and then just putting it out there, like you said, is like the new file and patching the old one. It's kind of like copying.
Yeah, if you're applying patches, like let's say you've got source code for device driver, and you compile it and use that to build the binary device driver. And then the manufacturer says, hey, we've made an improvement, you should modify your device driver. They might send you a patch file that updates the source code, which might be significantly smaller than sending you the entire new source code, which might be, megabytes worth of files. They could just send you, a 10-line patch file that'll make some changes, and then you would make those changes in your copy of the source, recompile, and you get a new binary from that.
Okay.
Yeah. It's good stuff.
Do you know, or I mean, I'm sure we're going to do some of that stuff when we go to university, but like, are we going to do any of that stuff in like winter and spring?
We're not going to play with patches. If you do more group work, you might start to get into some of that on your own. But by and large, I think that's a little bit fringy, a little bit outside of the mainstream from what we'd mostly be doing. And things like Git kind of like takes care of that in a lot of ways. If you're doing development on a team and somebody makes a change to a file, when you say git pull, Git will automatically figure out how to take what you've got in your copy of the repository and update it to look like what's supposed to be in there. And so that's kind of happening in the background for us.
Okay.
But you can look at the manual page for patch and difference and play around with it, and it's a good thing to know. So apply a diff file to an original. And you can get into all kinds of excitement with this. But it goes along with diff. Alright, so sed, another thing we can do is we can negate a condition. So if we do this, we'll print lines 3 through 5 of our foods. If we say 3-5 exclamation mark, we'll print everything except lines 3 through 5. So it negates this condition. And it says, hey, if you don't satisfy this condition of being between lines 3 and 5, go ahead and print your input line. So that's another possibility. Alright, let's see. What else do I want to tell you here? So here's a file, and instead of /bin/bash, my shebang is saying user bin sed. Right? How do I know it's user bin sed? I can say which sed, and it will tell me, oh, it's just bin sed. Okay. So sed is located under /bin. So I'm going to make a file called with a shebang that says /bin/sed -f, which means I'm going to specify a program. And then the program I'm supposed to specify is just say append, and I'm just going to do a / and say add, you know, a blank line to the end of the input line. And so if I say space foods, it gives me my output as a copy of my input, but with an extra space added after each line. So space is now, you know, my like double space program. If I say space ~/.bashrc, it gives me a copy of my bashrc, but double spaced. So you have to write a 10-page essay and you've only got 5 pages written, you can just run it through a space command and now you've got a 10-page essay, right? No, don't do that. But, you know, so just like awk, we could make a script that instead of being run by bash is run by sed, and we can embed the program right inside this, and now this becomes, you know, something that we can use as a new built-in command of our own creation to do some modification on a file. All right, so that's the basic setup. Oh, let me show you one other thing we can do with sed, but also with VI. This is a useful trick to know. So when we do like substitute /old/new, we don't have to use a slash. I could say substitute ~old ~new. And it works exactly the same as substitute /old/new. But since I'm saying substitute tilde, it's using a tilde to know what's the old, what's the new pattern. And this is nice if you want to change something containing a slash, for example, right? If I have a pattern with a slash in it, and I say substitute /old, but this string has a slash in it, it's going to take that as the end of the old part and the beginning of the new, and so on. So for example, let's say I want to take a path, which, you know, is usually a bunch of things specified with slashes in between, and I want to change those slashes to underscores. So I could say substitute // with underscore, and it's not going to know what the heck I'm talking about, right? But if I say sed substitute &/ underscore globally, right? This is saying, you know, replace slashes with underscores. So I can put in, you know, a path like this, and it changes the slashes to underscores. So we can use something other than a slash to say, hey, you know, everything between this and this is the thing I'm looking for, and everything between this and this is the thing I want to replace with. And so that's just a useful trick to keep in mind. And that works in VI, it works in sed, and it saves us from having to escape. The other option is, I think this will work. Right, so we can put an escape in front of that slash to say, hey, this isn't the end of the old pattern, this is literally a slash. But sometimes it's easier to just do this. All right, I think that's pretty much all I wanted to do about sed. like I say, it's just another thing to kind of keep in your toolkit. You can certainly live without it, other than, you know, maybe this basic substitute /old/new. That's a really useful thing to know. But this larger scope of set as a programming language, you can probably live without that. I think I lived without it for 30 years before I started learning how to do this stuff. But you know, it can be useful if you're comfortable with it. Yeah, so the G at the end, I was taught that stands for global. I don't know if that's true or not, but I think of it as saying, you know, do the substitution globally. Do it everywhere that you can possibly do it in the line. So yeah, as someone said, it repeats the process throughout the line. And if I didn't do that, then it would only do a single substitution. So my first slash got replaced, but not the rest. All right, so where does this leave us? So no classes for the rest of the week after today at Clark. So Monday I want to start talking about processes, and I want to look at processes in Bash. And so we've done things, you know, like the PS command, where we can see what processes are running out now, or ps-elf to see like every process on the system. So I want to look at this in Bash in a little more detail. I want to look at managing processes ourselves, so running jobs in the background, using Control-Z the proper way, because we can use Control-Z sometimes. If we've got a program running that's taking a lot of time, if we want to kill it, we can hit Control-C. If we want it to keep running, but we still want to be able to do other things at the command line, we can do a Control-Z and what's called a BG, a background, to get the job running in the background so we can still interact with the bash shell. So I want to look at Unix side aspects of processes, as well as the concept of signaling. So what happens when we hit a Control-C? How does that kill the program, and what can we do if we don't want Control-C to kill the program? And then I want to, if time permits, I want to look at this from the side of C programming, and see how some of these things happen in C. How do we create processes? How do we signal processes? And so on and so forth. And that's something that you'll delve into a lot at a university. But I like to do kind of a first pass over that in 224. And we've got a week left. So we'll be able to get into that in a little bit of depth. I'll probably leave one day at the end of the quarter, you know, next Friday, to do some final review for the final exam. The exam will be a mix of programming questions, but also conceptual questions related to Unix and the shell and regular expressions and things like that. So we'll do that. I know I said I was going to do more ODPs. I think I'm probably going to leave ODPs for winter time. I think everybody's probably pretty slammed right now with work for this class, but also for other classes. And I think we're probably in a good place as far as topics. So I'll probably give the ODPs a break for the rest of this course. So upload your SLP if you haven't done it already. Finish PA5, get that submitted sooner rather than later if you can. And then you're pretty much set until the final exam. So keep coming to class. We'll talk about processes next week. That'll actually be a fun topic because it gets into a lot of weird stuff. And then final exam, check the exam schedule. I believe it's on that Tuesday of exam week. And then we're on for a big break. All right, so send me an attendance ping on the way out, please. And have a fantastic break. And I will see you all next week.
Just to be clear, only one person has to turn in the SLP if they're in a group.
That's
right?
correct, yeah. If you're in a group, long as the poster lists other people's names, you'll all get credit for it.
Thank you.
All right, have a good one.
Thanks. Have a good break.
Thanks, you too.